This set of Chapter 8 reading notes I'd like you to check on your own with the video versus spending the time to go through it in class. It's reading notes, so I think you probably got most of it. First, the four driving forces of the reaction. Notice that these four driving forces are also very, very similar to the signs of a chemical reaction. They are all signs of the chemical reaction, precipitate being the same, forming a gas, giving up bubbles being the same. The new concept and something that you cannot physically see is the transfer of electrons, and that has to deal with one of the reaction types that we are learning by definition only. Vocabulary: precipitate is a word that we've already had. A precipitate reaction is one where precipitate is formed. The DD stands for double displacement reaction. The term electrolyte is new, and we'll be doing a demonstration in class with that. We have talked about the terms soluble and insoluble, and soluble is something, as you can see, that dissolves in water. You will have to determine eventually whether something is soluble or insoluble, and you will do this by looking at a chart and a table that I give you in class. Okay, looking at the next section then for what it looks like for something to be soluble and something to be insoluble. Remember that soluble means dissolved in water, so all these red and white molecules that you see are the water. And if we assume that the blue and green is as a molecule of sodium chloride, you can see that the sodium chloride is being broken up and physically actually taken away and surrounded by the water molecules. So that is what dissolves mean, because from a practical point of view, remember that when salt is a solid, you can see it, but when salt is dissolved in water, you cannot. So in view C, all the salt molecules, all the individual ionic molecules have been surrounded by water molecules, therefore you cannot see it anymore. The second viewing then shows you what something that is insoluble. Again, all these little Mickey Mouse looking guys, those are all representing water molecules. So this molecule is something that is not dissolving in water. So our book does have a table on page 261 that you may use. There's also a table in class that we'll be using that is much easier understood. Okay, this next part where you are combining your potassium chromate and your barium nitrate. This is something I wanted you to look at just to get an example from in the book. This is a concept we will be covering at the very end of the chapter, possibly even after the test. So the first thing I do want you to know is the definition of a molecular equation. Molecular equations are the types of equations that we have been writing the whole entire time. And one thing also with this molecular equation, notice we have a compound plus a compound, so this is a double displacement reaction. So for your product, your barium has now combined with your chromate to make barium chromate. Your potassium has combined with your nitrate to make potassium nitrate. Okay, now these other two equations that you see are brand new. So a couple things to notice on them. First of all, by definition, you do have to know these by definition. The complete ionic equation, notice it uses the term ions. See how everything is broken up into ions because ions have a charge. They've taken the ionic compound and broken everything up. We are going to be spending a lot more time on this in class. This is simply an introduction. A spectator ion, we'll have that definition later also. That means an ion that is simply watching, like a spectator watching a basketball game. It is not a part of the reaction. Your net product is this barium chromate right here, which became the precipitate or the solid. So the net ionic, again, know the definition of net ionic is the ions, the two ions that reacted to make your product. The next part then with the strong acid and strong base, those are simply definitions I'd like you to know. Also, this one in C, the oxidation reduction reaction, we are not going to be talking about reactions in terms of oxidation reduction just yet. We do that second semester, but I definitely want you to know the definition. The book focused on that a lot more. We will not have near the focus that the book has. Finishing up then, With your net ionic of an acid-base reaction, again, here is the term net ionic. Notice the term ionic, ionic meaning ions. It's your hydrogen ion. The hydrogen ion came from the acid. We're just learning what acids are. The hydroxide polyatomic came from the base. Because the definition of a base is something that has a hydroxide polyatomic, definition of an acid is something that starts with a hydrogen. Again, this is just an introduction. Just know what I've diagrammed here. Two products of an acid-base reaction then are water and salt. And again, here is your acid-base reaction. Notice also an acid-base is also a double displacement reaction. Here's the oxidation reduction term again, and what I want you to know from here is C, that this is a transfer of electrons. It includes multiple types. The book puts much more of a focus, and we will focus on it second semester talking about batteries. C is what I want you to know right now, talking about the electrons that are transferred in an oxidation reduction reaction. The rest of the worksheet we will be correcting in class with all the examples of reaction types.